Hi, I am Gauri, EC department from Mahendra Engineering College for Women. Today we are going to see one problem in signals and system. So this problem comes under unit 5. Find linear convolution of x of n that is equal to 1, 2, 3, 4, 5. So x of n 5 samples and h of n, this is the sample, using graphical method. First of all, we have to find the number of samples. So finding number of samples, n is equal to, so this is x of n samples. For x of n, we have 5 samples. 1, 2, 3, 4, 5. So 5 samples. And h of n, 1, 2, 3, 4, 5, 6. So we are having 6 samples. So this is x of n samples and this is h of n samples and minus 1. So this is the formula. So 5 plus 6, 11. 11 minus 1, we are having 10 samples. So for this problem, we are having 10 samples from 0 to 9. So we know about that linear convolution formula, y of n, that is equal to summation k equal to minus infinity to infinity x of k h of n minus k. So for this n, we have to substitute from 0 to 9. So for n is equal to 0. So first finding x of n using graphical method. So for graphical method, so this is the x of n, x of k. So for time period 0, we have the amplitude 1. So for 0, the amplitude is 1. Then for 1, the amplitude is 2. For 1, the amplitude is 2. Then for 2, the amplitude is 3. For 2, the amplitude is 3. And for 3 time period, the amplitude is 4. Then 4, the amplitude is 5. So this is x of k and h of n. So h of n graphical method, 0 and x-axis k, this is h of k in y-axis. So we are having 6 samples. So 0, 1, 2, 3, 4, 5 for 0. So here there is no arrow mark is given. So the first value takes 0. So for 0, the amplitude is 1. And for 1, the amplitude is 2. For 2, the amplitude is. So this is 0. This is 1. This is 2. And this is 3. This is 4. This is 5. So for 0, it is 1. For 1, it is 2. For 2, it is 3. 3 also, the amplitude is 3. And for 4, the amplitude is 2. Then 5, the amplitude is 1. So we are putting the graphical method for x of k and h of k. For n is equal to 0, y of 0, that is equal to summation k is equal to minus infinity to infinity h of k, h of n minus k. So for n, we are substitute 0. So h of minus k. h of k, we have the graph for h of minus k. So we know the h of k graph. So from h of k, h of minus k is reverse the h of k. So this is k and in y-axis h of minus k. So for 0, there is no change. For 0, the amplitude is same, 1. And for 1, the amplitude is 2. So here 1. The reverse is minus 1. So for minus 1, the amplitude is 2. And here plus 2, the amplitude is 3. So minus 2, the amplitude is 3. And likewise 3, here it is minus 3, the amplitude is 3. And 4, here minus 4, the amplitude is 2. And for 5, here minus 5, the amplitude is 1. So this is h of minus k. So we know h of minus k and x of k. So substitute here x of k and h of minus k. So both in multiplication. So x of k dot h of minus k. So here its value starts from 0 and here also it starts from 0. Compare x of k and h of minus k, and so here for 0 the amplitude is 1. So here x of 0 dot h of 0 value, then plus x of 1. So substitute k from 0 to 1. So first 0 value, then x of 1 dot h of minus 1. So here it is minus k. So minus 1. Likewise it goes up to 9. So we are having 10 samples from 0 to 9. So from 0 it goes up to 9. See x of 0 dot h of 0. What is the value for 0, x of 0? So for 0 the amplitude is 1. So 1. And then for this is h of minus k. So h of minus k graph amplitude for time period 0 the amplitude is 1. So dot 1. Then next x of 1. So what is the value for x of 1? The amplitude is 2. So 1 dot 1 plus 2 dot h of minus 1. So here h of minus 1, but here the value is 1 and this is h of minus 1. Not the values are common. So we are having 1 dot 1. So 1 dot 1 the value is 1. So y of 0 is equal to 1. Then substitute n is equal to 1. So for y of n, that is equal to summation k equal to minus infinity to infinity x of k h of 1 minus k. You see here it is h of minus k. So for 1 minus k, see 1 minus k that is equal to 0. So for k that is equal to 1. Positive value. So shifting 1 times positively. So shift towards this positive side. So this is h of minus k and we are going to shift in positive side because we are having the value k is equal to 1. So k is equal to 1 means 1 time shifting. So for 0, here it is the amplitude is 1. So 1 time shifting, positive side, we are 1 time shifting the value. So here 0 the amplitude is 1. So 1 the amplitude is 1. And for minus 1 the amplitude is 2. So for 0 the amplitude is 2. And for minus 2 the amplitude is 3. So minus 1 the amplitude is 3. So likewise 1 times shifting towards positive side. So we know now h of 1 minus k and x of k. See, compare both x of k and h of 1 minus k. Compare the time period. See, what is the common value? For 0, here also 0, we have the amplitude. And for 1, we are having both the amplitude. But for minus 1, minus 2, here there is no value. That is amplitude is 0. So whatever value in multiplication we have, so 1.0, 2.0 means we have the answer is 0. So compare both x of k and h of 1 minus k and see only the common values. So first x of 0, see x of k, for x of 0 the amplitude is 1. So 1 dot, here for 0 the amplitude is 2, 1 dot 2 plus. Why we are putting here plus symbol? Because it is in summation. So plus, then x of 1. What is the value for x of 1? Here it is 2 and here it is 1. So 1 dot 2. 1 dot 2 plus 1 dot 2. So otherwise here it is 2 dot 1. Both are same. So for x of k the value is 2 and for h of 1 minus k the value is 1. So 2 dot 1. 1 dot 2 the value is 2 plus 2 dot 1 the value is 2. So y of 1 is equal to 4. We find out y of 0 and y of 1. Next y of 2. See, likewise for y of 2, substitute h of So what is our formula? Y of n, that is equal to summation k equal to minus infinity to infinity x of k h of n minus k. Here the value is 2 for n. So 2 minus k. So in that 1 minus k, so 1 time shifting. Here 2 minus k, so 2 times shifting in positive side. So see, 2 times shifting. See here. So here it is 1 time shifting. It goes to 1. So again 1 time shifting. So 1 time shifting means we are having h of 2 minus k. So 1, here the amplitude is 1. Then this is goes to 2. See, for 2 the amplitude is 1. For 1 the amplitude is 2. And for 0 the amplitude is 3. Minus 1 the amplitude is 3. And then minus 2 the amplitude is 2. Minus 3 the amplitude is 1. 1 times shifting in h of 1 minus k. So we can get h of 2 minus k. Compare this h of 2 minus k and so this is k and this is x of k. So for 0 it is 1 and for 1 it is 2 and for 2 it is 3. For 0 it is 1, for 1 it is 2, for 2 it is 3, for 3 it is 4 and for 4 this is 1, this is 2, this is 3, this is 4, this is 5. Compare both the graph. We have the common time value 0, 1, 2. Here also 0, 1, 2. So we are having 3. See, for here 0, the amplitude is 1, 1 dot. Here for 0, the amplitude is 3, 1 dot 3. Plus for 1, the amplitude is 2. So 2 dot. Here for 1, the amplitude is 2. So 2 dot 2. Plus here for 2, the amplitude is 3, 3 dot. For 2, here the amplitude is 1. So 3 dot 1. So 1 dot 3 is 3 plus 2 dot 2, here it is 4 plus 3 dot 1, it is 3. So answer is 10. Okay. So y of 2. Then y of 3. So up to, we have to find y of 9. We have 0 to 9 samples. So y of n, that is equal to, this is 0, this is 1, this is 2. So this is y of 0 value. This is y of 1 value. See. So we are finding y of 1, that is equal to 4. Y of 2, the value is 10. Y of 3, the value is 19. So from y of 2, y of 3, we have to find y of 3. So this is h of 2 minus k and this is h of 3 minus k. So from this, again we are shifting 1 times towards positive side. Likewise here, this is h of 4 minus k. So from this graph, we are shifting 1 times towards positive side. Now we are getting h of 4 minus k. Again for h of 5 minus k, from this h of 4 minus k, 1 time shifting towards positive side. So likewise, we are finding all the values. Y of n, that is equal to, for y of 0, the value is 1. For y of 1, the value is 4. Y of 2, the value is 10. Y of 3, the value is 19. And likewise, this is 3, this is 4, this is 5, 6, 7, 8, 9. So we are finding how much values? 10 sample values. Okay, thank you.